So this is specimen paper 2018 paper 1. Question number 1 says a sample of magnesium consisting of three isotopes has a relative atomic mass of 24.31 gives the relative abundance of the two isotopes. Use this information to determine the relative abundance and hence the mass number of the third isotope. Give your answer to the appropriate number of significant figures.
Um. Okay. 1 second. I'll just get my calculator.
Okay, okay. So in this we are going to apply AR is equal to, if you remember, AR is equal to isotopic mass multiplied by its abundance,
I'm back.
right?
Yeah. Yeah.
Yeah,
Yeah.
so
I know how to do this. I remember.
yeah, it's gonna be
1 second. Just give me a second. I'll calculate it.
it's of 4 marks. Okay. So they are saying that consisting of three isotopes has a relative atomic mass of 24.31. So they have given you the relative abundances of the two isotopes. Then we have to identify the abundance of the third one. It's gonna be percent abundance of the third one is equal to 100 minus 78.8 plus 11.7. It's gonna be 9.5%. Now we know the relative abundance of the third one. I am going to apply the formula. AR is equal to, AR is given, that is
So can you tell me the final
24.31.
24.31
24 times 78.8
is the answer
plus,
26? Is the answer 26?
yup, yeah,
Right. I'm getting that.
11.7 plus 9.5x divided by 100. So x would be equal to, you are saying 26, right? This is 26. Okay, so 4 marks, it's 26. Describe how ions are formed in a time of flight mass spectrometer. How the ions are formed in a mass spectrometer. If you remember, we have attached the filament which was releasing high energetic electrons, and the electrons was bombarding on a sample. The sample can be anything. It may be chlorine, it may be bromine, it may be methane, it may be anything else. So the thing is that highest voltage is applied to the sample. Okay, so when we are going to do high voltage, so it's going to release high energetic electrons will be bombarding with the sample, and so that the sample is going to give away its electron, it's going to form a cation. Okay, so it's of 2 marks. It's of 2 marks. I can say atom, atom loses an electron, atom loses an electron as on a sample high voltage is applied. A time of flight mass spectrometer can be used to determine the relative molecular mass of a molecular substances. Explain why it is necessary to ionize molecules when measuring their mass in a TOF mass. Like why it is necessary, why it's mandatory to an ion. Why not we are going to determine the neutral one? What's the reason?
The ions, because they're unstable, so
Or
it's like they're unstable, so it's easier to like measure the electron's mass.
Um, okay.
But
If
I'm
you
not
remember,
exactly sure.
yeah, if you remember, I have drawn this diagram. This is the ray diagram in which I have attached a hollow disk having a negative charge. This is the negative plate. These are the filaments. This is sample. The sample becomes cation over there. The sample is going to attract by this plate and it would be accelerated in the presence of this negative plate and will be detected by the detector. Of course, then we have applied the magnetic and electric field on the basis of the charge and their masses. It's going to be detected by the detector that is present over there. So the thing is that in a mass spectrometer, always electrons are removed and always cations are formed, not the anions. And if the cations are formed, that can be accelerated by the negative plate, the disk, which is going to have a negative charge. So as a result, the ions would be accelerated by this plate and the ions will be detected by the detector. That's why it's mandatory to form an ion. Otherwise, if you have a neutral species, it cannot be detected by a detector. Another thing is that we must have a cation, not an anion. Remember. So the thing is that uh, after after losing electron, ions are formed, especially like of course cation is formed that will interact that will interact and will be accelerated by an electric field and this ion will create a current when it would be hitting the detector. That current will be detected by the detector in the form of a signal. It would be giving you the mass spectrum. On the basis of that spectrum, we would be determining the sample. What the sample is that I can say um, chlorine, bromine, iodine, astatine, whatever the sample is. Okay.
Okay.
So see this one.
So you can use a current to find the mass.
Yeah, we can identify the MR by the mass spectrometer. We can identify the percent abundance by the mass spectrometer. So these are the things that we can determine through this one.
Okay. All right. So we are going to use ions, right? So
Sorry.
for the equation of this one, I think it would be
Okay.
Ca plus
What's
Ca
the state
plus
sample? What's the
all
state
are
sample?
gaseous gaseous,
Good.
and
Yeah.
charge would be plus, right?
That
Plus, and
this
then
one?
you're gonna draw an arrow.
Why? They're asking about the first ionization energy. Initially, the element is not supposed to have any of the charge. After
Oh, okay,
it
okay. So no
it
charge, and
loses
then you're
its
gonna write the
electron.
arrow. Yeah,
Yep.
electron plus calcium minus. I mean plus. Sorry, not minus. Plus and gas.
Yep.
Yeah. Okay.
Yes. Okay. State
Energies
and
and explain.
explain the general trend. Okay. Period
Yeah.
two. Boron two. Boron.
So
Uh,
across a
boron, carbon,
period,
nitrogen, oxygen. Hmm.
um, across a period, uh, like if I were to think, I'd say that across a period, electrons increase. There is no change to the shielding, but repulsion increases from the nuclear to like the positive charge and the electrons, like the repulsion increases basically, right? So
Hmm.
I think the ionization energy increases across the period, right?
Yeah, because the size is going to decrease, isn't it?
Yep.
And what should I explain? It's of 3 marks. I
Wait,
got
wait.
one
You
mark for
said
this one.
sir, you said size decreases?
Yep, the size decreases. That's why ionization is going to increase.
Right, right, right. Is
And
it
then
because
why the
there
size
are more
decreases?
electrons? So, like, attraction between the nucleus and the electrons increases, yeah? That's why.
Good, 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 good. Okay, it's of 1 mark. And what you would be writing for and another mark?
I'd say atomic radius decreases
Or
like there is no shielding effect or anything.
atomic
Electronegativity,
radius.
electronegativity
No, no, no. Atomic radius decreases
due
due
to
to
electron attraction between the nucleus and electron increase.
increase in nuclear charge.
Hmm.
You know, nuclear charge means when the number of proton increases in the nucleus of an atom, an outer electron increases. So, of course, the force of attraction between the nucleus and the number of protons increases. So, that's why nuclear attraction increases. As a result of this, atomic size decreases, and that's why ionization energy is going to increase. Okay.
Right, yeah, that makes sense. Okay.
There is a similar general trend in the first ionization energies for the period 5 elements indium to xenon. Okay, state how tellurium deviates from this general trend and explain your answer. I have to see the proton number of tellurium. What's the proton number?
Of tellurium. 1 second.
Mhm. Mhm.
Tellurium. They're saying what period is this in? Period 5. Tellurium is tellurium's atomic number is 52,
Okay,
and indium
52.
to xenon general trend. Yeah, tellurium is 52.
Tellurium is 52.
Indium to xenon. Tellurium for like first ionization energy. Shouldn't they all be like increasing like from indium to tellurium, like from the left to right?
Yeah, that's the fact that across the period atomic radius decreases, so the ionization energy increases. But But of course, when they're asking, it would be just like beryllium and boron, nitrogen and oxygen, magnesium and aluminium, phosphorus and sulfur. If you remember, they were deviating from the normal behavior. So that's
I
the
don't
same for
remember.
this one.
What do you mean by deviating? Like they
Like
don't
I
follow it?
want to say, yeah, exactly, because when magnesium is 12 and aluminium is 13, if you remember. So it should be like if we say that ionization energy increases across the period, so aluminium is supposed to have the higher ionization energy than magnesium. But the thing is that magnesium is higher than aluminium. What's the reason? Then we did an electronic configuration, then we saw that the
Unstable.
configuration for magnesium is ending on 3s2, which is fulfilled, which is more stable. More energy would be required to remove an electron. And when we did an electronic configuration for aluminum, so it was ending on 3p1, which is the fifth orbital, further away from the nucleus. It's partially filled, it's unstable. Less energy would be required to remove an electron, so that's why aluminium is lower. Same goes for indium too.
Um,
So how
Sir,
tellurium?
I have a
Yeah.
question.
Yep.
When an element is unstable, what does that mean? Like, could you just
It's
summarize
mean
it?
that it's mean that everything want to get stability, whether they lose electron, whether they gain electron. So that's why unstable species will be losing its electron very easily comparatively to get stability. So less energy would be required to remove that electron as compared to the one when you have the stable species, because stable means it doesn't want to lose its electron. It's already stable, half filled or full filled, let's say. So of course, if you want to remove that electron, so more energy would be required. That's the reason. That's the difference between the more stable and the less stable. Okay.
Okay, got it.
So tellurium. What's the group? What's the group for? Let me see the periodic table.
Tellurium is in group number 6.
Tellurium is in group number 6. So
Yep.
in group 6, I have phosphorus and sulfur. Phosphorus is in group 5, sulfur is in group 6. So if you remember, sulfur was having the lower ionization energy, if I'm not wrong, because it was
Compared to
3p4 and it was 3p3.
compared to
Yeah,
like phosphorus, yeah, it is, yeah, like that.
yep. So the same goes for tellurium because it's the same group. Period is changed, of course, but the group is same. So the ionization energy would be lower. Ionization energy would be lower. Ionization energy of tellurium is lower. Why it's lower? Why it's lower? Because the thing is that um, when the
It's
ionization
unstable.
energy is lower, so yeah, so we have to see tellurium is in
Do I
group.
write like the electronic configuration of tellurium?
Yeah, it would be easy for you.
No, like to get a mark or something.
No. You have to talk about the paired or unpaired electron. So of course, then you
Okay.
have to see the periodic table. Yep. So
Sir,
it would be
okay.
ending on, yeah.
No, no, go on.
Okay. So can you give an idea what would be the configuration for tellurium? I'm only asking the last one. Like let's suppose it's gonna be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, and 5p4. It's 5p4. It's ending on 5s2 and 5p4. So means that this is in the fifth period. Means that this is in the fifth period and it's in the 4 plus 2 sixth group. If I'm not wrong, It's the group number and the period number. It's 5p4. 5p4 means what? 5p4 means that it's gonna be 3p has three orbitals. 1, 2, 3, 4 means that it's partially filled, and not only the partially filled, but you can say the electrons are going to have a repulsion. It's called a spin pair repulsion. It's called a spin pair repulsion, which makes it unstable. As a result, less energy would be required to remove an electron. That's why tellurium has a
By the way,
lower
sir,
ionization energy.
I didn't remember the spin pair repulsion thing. Is it like part of my AQA thing?
Of course.
Like, am I forgetting it or it's what?
Yeah, obviously you are forgetting this. This is the part you have to write it down. You
I
will be
didn't
getting the
remember that.
marks for this one. Yeah.
Spin pair repulsion, it's like a keyword?
Yep.
Okay. Also, sir, in like group 5 then, like do all of the elements follow like the same trend, like their electronegativities are uh like lower compared to the other ones, like they don't follow the trend in like group 6 or something? Or is it only
Basically,
this
you will be
tellurium?
no, it's only the tellurium basically. That's why they are asking. But I took an idea from phosphorus and sulfur, magnesium and aluminium, beryllium and boron, nitrogen and oxygen. So if you will be going down, so those elements would be having the same trend. You can try the electronic configuration and you can see the data of the ionization energy. It should be it should be higher, but, when you will see, then you will come to know that it's
Wait,
lower,
like
and you can
could
define
you
it.
name the elements again, like slowly? Magnesium, there's magnesium, and what else?
Magnesium and aluminium,
Hmm.
phosphorus and sulfur,
Okay. Like these two only.
nitrogen and oxygen,
Yeah, nitrogen and oxygen, phosphorus and sulfur are
magnesium and aluminium, beryllium and boron.
no, so also like arsenic and selenium, for example, in group 4. Like that's what I mean. Like all of the ones in group 8 aren't following the uh thing, right? Or are they?
In group 4,
In group 6, sorry, group 6, not 4, sorry, 6, 6, 6.
yeah, all would be having the same.
Okay.
Why the first ionization energy of xenon is lower than the first ionization again? Xenon is lower than the first ionization energy of krypton. Of course, they are present in the same group. Xenon is also the member of noble
No,
gas.
xenon is like lower than krypton, you're saying.
Oh, okay. So they're in the same group, isn't it?
Yeah, so xenon,
Yeah. So why the first ionization energy of xenon is lower?
because like both of them are stable, right?
Of course,
So like due to more repulsion, atomic radius increases.
due
Like
to more repulsion, atomic radius increases.
yeah, so it's like
Yeah, so
easier for the electron to
yeah,
leave.
yeah,
Yeah,
that's why xenon is lower, right? Xenon
right.
is xenon has xenon has bigger size, isn't it?
Yep. Yep. Exactly. All right. Thank you.
Due to more shielding, so electron can be removed easily. Okay, good one. Deduce the group in the periodic table that contains the element. Okay, 2.5. Yep.
So the largest difference is between second and third. So I think it's in the second group, right?
1400 to 7000. 7000 to 10,000. 10,000 to 30. Yep, it's in the second group. Good, 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 good. It's of 1 mark. So the group number is 2. Group 2.
Group 2. Yeah.
Uh, oh, 5 plus ion with an electron configuration of this one. Okay. Okay.
Okay.
Okay.
Once when 5 plus ion, that means that it has lost 5 electrons, basically.
Yeah. And after losing 5, the configuration is this one. It's gonna be, this is 10,
So it's 51,
20,
so it's the one before
28,
tellurium. So antimony, I
30,
think.
36, and
Antimony,
36 and 46. 46 plus 5.
51.
It's gonna be 51. 51 is
Antimony.
antimony. Okay.
Okay.
Antimony. Symbol is SB, right?
I think yeah. Sir, do you
This
have
is
like the
easy. It's a
entire
concept.
periodic table memorized?
Only few elements.
Okay.
Yeah.
Um, okay.
In the 1.48 gram sample, they're asking the moles. Of course, the mass is given. We have to see the MR. Iron.
Hmm.
What's the formula for iron 3? Iron 3 nitrate, right? So this is going
Fe3.
to be, this is iron 3 nitrate, right?
So iron's
Or
thing is 55.8, 55.9.
1.40. This is going to be 56 plus nitrogen is 14 times 3. Oxygen is 16 times 9.
Right. Uh, okay. Right. And you're gonna multiply, right? Okay. Okay. Right. That's 1.48, right? Okay.
1.4.
Yeah. No, no, nothing, nothing. Sir, for the moles, yeah, the moles chapter, there are more equations, yeah. Like, okay, the answer for this is coming out to be 6, like 0.006, 0.006, 612.
Okay.
That's the
So,
answer in the significant
okay.
figures. Yeah, I was saying that for this mole part, there are like more formulas. Like I think using the Avogadro's number, there's also a formula to find out the mass, right?
Mm-hmm.
So if you have that in like some PDF or anything, just do send that to me because I don't have like those formulas memorized. I have these simple ones, but not those
Okay,
ones.
okay, okay. Okay.
Okay. So we have the moles and
Then they're asking the moles of oxygen.
yeah. So in the molar ratio of 4 to 3, we can find out that easily. So 0.00612, 0.00612 times 3 divided by 4 is gonna be 0.00459.
It's gonna be x. Then x is equal to 0.00.
459.
Okay. It's of 4 marks. Calculate the volume in meter cube of NO2 gas at 39293. Okay, 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 okay. Then we have to apply the formula PV is equal to nRT to get the volume in meter
Yep.
cube. Automatically, I would be getting the volume in meter cube. I am not supposed to convert the volume.
Right.
So,
The
uh,
Pascal, you have to change it into just normal Pascal instead of kilopascal, and the temperature, I think you have to change it into Kelvin,
what's
which you
the
have right
mole?
now.
What's the mole? Oh my God. Wow, I have to calculate the moles of NO2. Okay. Through the same equation, I have to calculate the moles of NO2. It's
We
gonna
we already
be
have the moles. We already have the moles in 3.1.
mm, mole ratio
We
is
found
4
zero
is
point
to.
zero zero. We
I
already
found the
found the
moles of
moles, no?
oxygen. They're asking NO2. They're asking NO2. 4 is to 12.
Oh, okay.
4 is to 12. 0.00612. It's gonna be X.
Oh,
X is equal to what?
X. Sir, they're asking for. Okay, okay. Never mind. Right. We need to find NO2.
Yep.
Okay. 0.00612 times 12 divided by 4 is gonna be 0.0184. 0.0184.
0.0184 multiplied by R, that is fixed. That is 8.31 multiplied by temperature. They have given to you that is 293. We have to convert this degree Celsius into the Kelvin. I'm supposed to add 273. I would be getting 3 plus 3, 6, 7 plus 9, so 16. So 1, 2 plus 2, 4, and then 5, 566 divided by the
566. Yeah.
pressure, divided by the pressure. So the pressure is going to be 100
Pressure is
kilopascal.
in
So
kilopascal.
we have to convert it in Pascal so that I would be getting the volume in meter cube, right? So what should I write
Yep.
in order to convert the kilopascal into the Pascal? 100 times 1000, isn't it?
You have to 100 times 1000, which is gonna give you 0.000865.
0.
Three zeros. 0.000865.
Okay, that's
Yep.
the answer. Suggest a name for this type of reaction that iron 3 nitrate undergoes. What's that? What's that? Iron 3 nitrate
Iron 3.
undergoes. Okay. So 1 to 3.
One
One
second.
reactant, 3 products. What does it mean?
Oh, sir, the MR of iron was given. You didn't have to like calculate it. I just realized in the question,
Where?
like at the very start.
Oh my God. Oh, okay. Yes. Yep. Okay. What's the type of reaction? One
Can you show
reactant
me
and
the
3
equation?
products. One reactant
Can you
and
show me the
3
equation?
products.
One reactant and three products is a decomposition, I think.
Exactly. What type of decomposition? It's a thermal decomposition.
Thermal decomposition. Right. Okay.
We can also decompose the compound by means of electricity, which is called electrolysis.
Right.
Break down the
But that's not
compound,
a
yeah?
type of reaction, no? Is that electrical decomposition or
Yeah,
something?
yeah, exactly.
Right.
You can say. Suggest why the iron 3 oxide obtained is a pure. Assume a complete reaction.
I don't know. What do they mean? Like, what do they even mean by pure?
If you can see this equation, we have the 3 products: solid, plus
FeCO3.
gas, and then plus gas. So all the other products are gases and iron oxide is a solid. What does it
Oh, I can
mean?
say,
It
sir.
means
Uh, can I say the temperature is like very high because of that? It's pure.
no. Basically, from the gaseous products, it would be very easy to separate the solid. If you will be having more than two solids, it would be difficult to separate them out. So, might be possible there would be some impurities. Of course, the sample would be mixed together. So, if you have one solid and other two gases, so this is good. This is easy to separate the solid. So because all the other products are gases, so I can say that yes, the iron 3 oxide obtained is pure because other products are gases. So you can separate iron oxide easily because the state is different.
Oh, okay. Like there are no basically like impurities or something like with iron, right? Okay.
Okay.
Okay. Aluminium bromide. Wait, so do I use bromine? I do, right? Why have they given me thallium?
Yeah,
No, like
we
why
have
have they
to.
in
They're
thallium?
saying they are saying formation of aluminium bromide. Formation of aluminium bromide, that is going to be AlBr3. From its elements, the elements are aluminium plus bromine, that is Br2. We have to balance the equation.
Right. So
How can I
we
balance
can
this?
say you can write on the right hand side you can write two, I think, and 2Al plus 3Br2.
What if I write this one?
No, you'll have to
Short.
multiply it then, right?
Yeah, you can also write this one, 2, and then
2Al and 3Br2,
over there.
and
It's
on
the
the right.
same thing.
Really? You can write it like a fraction. You can do that.
Yeah, exactly. You can also write in, you can say in decimal. Yeah, 3 upon 2 and also 1.5.
Because in sir, the thing is, I never did that because in IGCSE year, they told you that you have to have him in whole numbers.
Oh, you will amaze to see your marking scheme. I've seen a lot of times.
Really?
Before your class, I was taking another one. Yeah, it's easy to do this. Otherwise, you have to go to the whole number. But you can do
Yeah,
this. Don't worry about that. Okay.
I didn't know
Yes.
that. Okay, thank you.
Okay. 4.2. It's easy. It's related to
The
chemical
thing is,
bonding.
sir, I haven't done any past papers for chemistry until now. This is like my first one ever. So I haven't gone through the mark scheme either. So I don't know how to
Oh,
answer the question
okay,
exactly.
okay, okay. See this one?
Yeah. Uh, is this like the dative bond or something?
Mm, yeah, if you remember, we were doing this one AlBr3, it would be reacting with Br, it would be forming AlBr4 minus. So means that it's going to form a dative covalent bond. So I have to write type of bond as dative covalent. Dative covalent.
Right.
And how you will be explaining this?
Uh, like there's like a lone pair of electrons on bromine and or like bromide on like sorry, the aluminium, so it can like share its electron with the bromine maybe.
Yeah, electron pair on donated to AlBr3.
Right, because there are only
Yeah.
six right now and
Deduce the
it's like
formula.
outer.
Yeah. Aluminum bromide
Sir,
has
I
a
don't get
relative
one thing.
molecular
I don't get
mass.
something. I don't
Mm,
get when there is Br minus, right?
mm.
That means Br has like a outer shell of two extra electrons or like one extra electron.
Yeah,
Like
that's two extra
it
electrons. That's why basically it has a lone pair of electron, and where the bromine comes from. The question is that it's Br2, right? It's Br2. So what's going on over there like that? It's taking away its electron. So
no.
it's
Look.
this
I
one
don't get
and it's from
one
this
thing
one.
that sir, they have written Br, right? Like only Br. They haven't written
I got your
Br2.
answer. No, so we know that the BR is coming from BR2, of course. Common sense. You can see
Yeah,
this one.
okay.
If they are
But
saying with a
look,
bromide ion, what does it mean? Bromide
hmm,
ion, Br minus. So Br minus comes from Br2, of course.
okay, but look, a bromine, yeah, a bromine, like the element bromine, has seven electrons in its outer shell, right?
Yeah. So
So
you can see
if
this
it
one.
has
See, see,
seven,
see, see. See this. See
yeah,
this. 1, 2, 3, 4, 5, 6, 7. That's okay? Okay?
okay.
One, 2, 3, 4, 5, 6, 7. When it's taking away this bond, so basically it's taking away both electrons, isn't it?
Oh, okay, I didn't know that. Well, okay.
Yeah. So that's why I'm saying that it has a lone pair of electron after getting the charge. And it has to give its lone pair because the data tells us it's the sharing of
Sir,
a
your voice is
lone
cutting
pair
out.
of. Yeah. I'm saying that what's the dative covalent bond when the electron pair is shared? When the whole electron pair is shared, not the single electron. Otherwise, if single electron is shared, it would be called simple covalent bond. It's not a simple covalent, it's a dative covalent bond because electrons pairs are shared. Okay?
No, no, okay, okay, sir. Okay, that's all right. But look, I'll tell you what I don't get, okay? Aluminium has space for two more electrons, right?
Yep.
So Br, bromine, the element has like an outer shell of seven, and when it's gonna be an ion, it's gonna have eight, right?
Yeah,
So
that's right.
when you say donate, do you mean like the two electrons from bromine go to aluminium, or like they're just sharing with aluminium?
Basically, they are just sharing aluminium.
They're not giving it to aluminium. It's not like
Yeah,
ionic
exactly.
bond.
Yeah, yeah. It's not ionic bond. All are non-metals. It's
Right,
not an
right.
ionic bond. Yeah.
So they're just sharing. Okay, got it.
Yeah, exactly. One-sided sharing of an electron pair. Whole
Then
pair
why
is
did you
being
use the
shared.
word donate? Why didn't you like just say share?
Basically, we don't use the word because dative covalent bonds are always polar. They are always polar, remember. So that's why we have to use the term they are going to donate its electron. They
Okay.
are they are
Right.
going to donate its lone pair of electron. Whole electron pair is shared.
All right. Okay. All right.
Has a relative molecular mass of this one in a gas phase. Deduce the formula of the aluminum compound that has a relative molecular mass of 523.4. Okay. It's easy.
Um, Wait. Aluminum bromide has a in the gas phase. Deduce the formula of the aluminum compound that has a relative molecular mass. What? What do I have to do here?
Let's say aluminium bromide is AlBr3. Okay. If it's AlBr3, what's the molecular mass of AlBr3? Is that going to be matched with this Mr? Isn't it? AlBr3, you have to find out the AlBr3 first. And if not, then you have to multiple it like that.
AlBr3. Wait 1 second. Uh, so okay. Wait. I'll find for AlBr3. Aluminum bromide has a relative of 53.4 in the gas phase. No, I don't get it. Could you repeat what I have to do?
First of all, can you tell me the Mr of this one?
AlBr3.
Hmm,
Okay. So aluminum is 27
hmm,
plus bromine is 80, right?
hmm.
So 267.
So means that it doesn't match with this one. So of course they are saying in a gas phase. Remember, in a gas phase, aluminium bromide combines with another aluminium bromide. It's going to form a dimer. It's going to form a dimer. Mer means part and di means two. So it's gonna form Al2. It's gonna form Al2 and Br6. Can you find out the MR of this one? Is that
Yeah,
match with
534.
this? Yeah,
534,
okay.
yeah. Yeah.
Yeah, so that's the formula of aluminium compound that has a relative molecular mass of 533.4. Okay.
So,
Deduce the
sir,
name and
when they usually give
hmm.
questions like this, yeah, is it like just like a multiple of two or multiple of three usually?
Yeah, and
Okay.
generally you will see AlCl3 as well. When AlCl3 combines with AlCl3, it's going to form Al2Cl6. When we were doing dative covalent bonds, so I have given you the 3 to 4 examples. One example was ammonia was reacting with H plus to form ammonium, and H2O was reacting with H plus to form hydronium, and AlCl3 was reacting with AlCl3. It was forming Al2Cl6, and BF3 was reacting with NF3, it was forming the compound. So basically the first species has a lone pair of electron and another species is seeking a lone pair of electrons. So that's why they are going to be shared between the two those compounds. One is electron poor and one is electron rich. That's why the dative covalent bond is formed.
All right.
See this one?
Uh, that has the same number of atoms, the same number of electrons, and the same shape. Same number of atoms. Yeah, this number of atoms has to do something with the moles. Yeah, I don't remember the formula.
Deduce the name or formula of a compound that has the same number of atoms, the same number of electrons, and the oh my god, as the same shape as the AlBr. First of all, what's the shape of AlBr4?
Um, I think it's going to be like how do I explain it? Like there's basically a dative bond like at the very top, right? So it's gonna be like with that angle is going to be I think 109.5 and like they're gonna be 3 BRs down maybe. I'm not sure. Think it would be that I don't know what it's called.
Yeah, I can write. Deduce the name or formula that has the same number of atoms. So it has five atoms, right? It has five atoms. Okay. So I can
Now how
say
did you find 5 atoms?
Al1 and Br4. So 4 plus 1, 5.
Oh, okay.
Same number of electrons and the same shape as the, its shape is tetrahedral.
We, there are four bond pairs.
Yeah, the four bond pairs.
Right.
Okay. I can say it's gonna be
So I was
the
right
same number
here.
of atoms.
109.5.
I can say SiBr4, 14 electrons, and Br is going to have, I don't know what's the proton number. Hopefully, if this is bromine is 13, so it's minus 1. Minus 1 means 13 plus 1, it's 14. So of course silicon is 14. So 110% it would be having the same number of electrons, and of course it has the same number of atoms as well. So the answer is SiBr4,
Oh, by the way, sir, I
isn't
have
it?
a
It's
question.
easy.
When you said the shape here, like in the tetrahedral shape, is like the top one like always like a, a dative covalent bond always or something?
In a tetrahedral.
Yeah.
No, it's not mandatory. CH4 is not tetrahedral. It's a simple covalent, but it's also a tetrahedral. It's not mandatory to have a dative covalent bond for a tetrahedral shape. No.
Then
You
why is it
have to
not
see if you
like
have
you said that it cannot be 90 degrees because it's unstable, right? Like there's repulsion.
90 degree. Why it's 90 degree?
No, because like all of
Yeah,
them.
90 degrees unstable. Yeah, that's it. Yeah, that's all. So,
Okay, okay, got it. All right,
yep.
all right. Okay. Shape of TIF shape. Oh, and
TIF. Nah, this is, I think this is, yeah, okay.
what is TIF? Like iodine, fluorine, and what is T?
Ti is the same thing. You have two elements and six atoms in total.
Is it Ti or TL? Is it thallium?
Yeah, I think so.
Right? It should be thallium. TL, TL, and F. Fluorine 5 with the 2 minus charge.
So five bond pairs in total, right? So if
How
you
did
have
you?
five bond
Yeah,
pairs,
5 bond pairs.
yep. So
Why did you just say it was 5 bond pairs? Like,
I saw the total number of fluorine, that's it.
what if? Okay, all right, all right. Like, what if fluorine doesn't have enough electrons to? Well, okay, never mind.
That's the shape for trigonal bipyramidal. If you have any of the element, so you can make the same shape, you can draw the same shape and just you have to put the elements. That's very easy. You have to just put the elements and that's it. So you have to
Okay,
memorize this kind of shape. Only this is the skeletal of
just like the
the general.
PCl5, right? PCl5.
Yeah, it's gonna be. It may be anything. Maybe anything. Okay.
Okay, got it.
Yeah.